everyone. Welcome to the IMSA webinar series sponsored by Applied Information this week. We are coming to you live from the iATL today. We are going to be talking about connected vehicles and providing emergency vehicle preemption and connected school beacon systems. But before we get started, I wanted to kick it over to Ashley from IMSA.
Hi everyone, thanks for joining us today. It should be a great presentation. I'm Ashley Burke, the Director of Membership and Marketing at IMSA, and we're so pleased to partner with Applied Information for this presentation. For our IMSA attendees, I wanted to give you a quick reminder that this webinar qualifies for continuing education credits, so be sure to add it to your training log on your IMSA profile. You can also now register for the IMSA virtual conference to earn CECs there as well, and you can find that on imsasafety.org/events. I'd like to now introduce today's presenter, Peter Ashley. He is the Vice President of Business Development and Marketing at Applied Information. Peter is live today at the iATL, the world's first infrastructure automotive technology laboratory. I'm going to hand it back over to Jessica, who will give you a quick rundown of today's agenda and then get back into the presentation.
Thanks, Ashley. So like Ashley said, we are here today live at the iATL. We're going to cover a lot of things today. We have about an hour. So just a quick reminder that if you guys want to learn more or want a private session, we are available to do that. So you can send a request for that to training@appinfoinc.com. I have Peter here with us. So we're going to start off with talking about preemption. We're going to do some interactive things. We are going to do the usual slides, but we're also going to see some videos, get up and do some touring, right? We're going to get our steps in today. We're going to do and look at the devices so we can see how these things are wired, and then come back and take some questions. We do want to encourage y'all to use that Q&A button that's in Zoom at the bottom and submit questions as we go, and I can interrupt Peter as he's talking. But let's get started, Peter.
Perfect. Thanks so much, Jessica. So today, as Jessica said, we're going to be doing a whole bunch of different things. I don't have enough time to really go into a lot of detail on emergency vehicle preemption and the school zones, because we've only got about half an hour on each. So I'm going to touch on everything. And as Jessica said, if you guys have got any questions or anything like that, please ask them, and we'll also schedule some sessions with everybody. So the first question, what is emergency vehicle preemption? So the main thing behind emergency vehicle preemption is providing green lights to emergency vehicles. Now, what we're doing is slightly different in terms of taking emergency vehicle preemption and also adding a whole bunch of other functions like connected cabinets, providing pass-through communications so that you can connect to your traffic signal controllers through your ATMS system. But I'm first just going to go in and I'm going to show a couple of slides over here. So I'm just going to pick up this iPad here and talk a little bit about emergency vehicle preemption. So the first thing is obviously you're utilizing multiple forms of communications, being 900 megahertz radio and cellular communication. And then, it's quite a quick and easy system to install. So what's really important is looking at how everything actually works. So you've got an emergency vehicle over here that's basically sending its GPS position through the cellular network, going up into the cloud and back down through the cellular network to the traffic signal controller. But at the same time, it's also sending it over 900 megahertz radio. So what's really important is to have a redundant system. So we've got redundant communication, a direct line of sight radio, well, sort of line of sight, and then the cellular communication. Now the cellular communication allows you to actually send this information much, much further away. So you can do over the hill, around the corner preemption. So there's a whole bunch of different functions that you can do. And when you're talking about transit signal priority, it allows you to also do a full cycle in advance so that you can keep your controllers in coordination. There's a big myth that if you do emergency vehicle preemption on your traffic controllers, it really messes up traffic in your city. Yes, in the past it did, but now all the traffic signal controllers are far more modern, that they're able to keep traffic controllers in coordination. Now, we're able to communicate to the traffic controller using a hardwired interface or NTCIP 1211 or NTCIP detector cores. So there's a lot of information that you can use to communicate to a traffic signal controller now through the Ethernet communication as well. So and at the same time, what's also really important on this diagram over here is you monitoring the system. You know, in the old school optical systems, to test if everything was working, you had to drive your vehicle to actually go and test whether or not this was working. These systems are now monitoring whether or not it's working and reporting and sending an email and text message as soon as there's any kind of failure or anything like that.
So Peter, I love diagrams, super cool, but is there any way that we can see this happening like in the streets, real time? Like what does it look like from the inside of a fire truck?
Absolutely. So what I would suggest is let's go and queue up a video over here inside of the inside of the fire station in City of Atlanta.
Okay.
And let's play this so that people can see what's involved.
Simply time. If you have a cardiac arrest, time. If you have a working fire, time. So everyone knows Atlanta traffic is super, super, super busy. So the fact that we can allow that traffic to move ahead, that gives us that open spot, we can get to the citizens a lot faster. It's tracking us via GPS and a couple of other systems. And what it does is as it tracks us and as we turn blinkers to turn left or to turn right, it will allow those signals to turn green, which moves the traffic before we get there. And then once we get to that particular intersection, we can move freely without stopping.
And I absolutely love hearing Chief Dwayne Johnson speak, because he talks about the importance of emergency vehicle preemption and all around the time aspect behind it. If you can save a couple of seconds, that's the difference between life and death. Now, in City of Atlanta, they've got extreme traffic congestion. And there were a lot of places they just couldn't use the streets. They couldn't get out of their fire stations. And now with emergency vehicle preemption, as soon as they turn on their emergency lights inside of their fire station, it talks to the traffic signal ahead and says, give us a green light. So what happens is it doesn't just talk to that first signal that's 500 feet from the traffic, from the actual fire station. It talks to the signal up ahead and the next one, so it starts triggering, flushing out the traffic ahead of that emergency vehicle. So the whole thing behind emergency vehicle preemption is to try and have something that's very, very flexible, that you can set up different rules that allows you to actually communicate to traffic signals ahead and actually make those changes. So one of the other things that is really, really important with emergency vehicle preemption is the data that's coming back. So if we have a look at some of the data, this is Odessa Fire Department in Texas, and they have incredibly active fire trucks. You can see they did 3,000 idle trips, 923 service trips, and 300 service trips that were outside of their city limits. Now, all of that's great. What's really important is what is their utilization of their emergency vehicles. So the utilization over here, you can see that it's available 81% of the time. And they're using it for emergency vehicles, 923 within the city limits. And what's important is this number here. Their average response time, and we averaging this over the whole month and over the 18 vehicles that they have there, is 3 minutes and 36 seconds. Now, what happened was when they were doing emergency vehicle preemption, they also saw information like the average travel time, which is 7 minutes for trips that are out of the service areas. So we have a 7-minute average response time for the trips that are mutual aid trips. So that's absolutely great for them to be able to look at their ISO ratings and see that they're meeting their ISO with 3 minutes and 36 seconds, and they're not taking into account their longer service trips. This is all information that's really great for the fire department. And what's also important is looking at where these trips actually occurred. So we can see over here, this is Saturday, and then, you know, the first day of the month, and then these are all the hours from 12 o'clock at night, 1 o'clock, and then you can see the heat map of when all the vehicles went out. At 3 o'clock on the 1st, they had 13 emergency vehicle calls that came in. So, you know, it was a high active area right around there. So that's a really important time that they needed to staff their facilities. So this allows everybody to actually go in and make sure that, you know, they're staffing their facilities at the right times as well. So some of the other interesting things behind this, some of the statistics that came out from City of Marietta that deployed the system for over 3 years, is they saw an average saving in the beginning of 10 to 12 seconds per intersection. And they were running through, on average, 6 intersections per emergency vehicle trip. So in the end, they were seeing about a 60-second savings from day one. Now, recently we had Chief Tim Milligan in, who updated us and said they're seeing round about 1.5 minutes now after going in and reconfiguring. In other words, they set up a system that their truck drivers provide information in terms of any traffic light that isn't green. Because when you're running emergency vehicle preemption, you should never, ever arrive on a red traffic light. So it's very, very important that any time that you don't get a green light in emergency vehicle preemption, it means something's not set up correctly. So what they do is they go back and they go and set up their preemption correctly and change their rules. So there's, you know, some real major benefits behind these systems.
Peter, before we move on quickly, I just want to kind of go back to that 60 seconds. I think we hear that number and we're like, 60 seconds, that must be super quick. But I remember that exercise. It was actually one of my first events at Applied Information, and you had us hold our breath for 60 seconds. And just picturing a loved one, like my grandpa who has, you know, severe health issues, or even with COVID happening now, and holding my breath for 60 seconds and just picturing how long that actually is. I think that's what is so super key when we're talking about preemption too, is yes, we're becoming more effective, but also at the end of the day, I think you had it on that slide, it's about saving lives, and that 60 seconds we've heard when it comes to drug overdoses or heart attacks are so crucial. And so I just wanted to kind of re-emphasize that point.
And you're absolutely right, because, you know, one of the things Chief Tim Milligan mentioned to us the last time was actually that a big problem is the opioid epidemic. And they have a special drug called Narcan that if they can get that drug administered to people on time, they are saving lives. So it's a key aspect there, Jessica, that absolutely right. In other words, how long is really 60 seconds?
Yeah.
You know, that's a really important thing. One of the things that I did want to just look at, you know, that's quite important is these are the actual physical units. So this is the unit that goes into the traffic cabinet. So we've got, you know, this is the front of the unit. It's a 19-inch rack mount unit. We do have some other units that you can put in as a shelf mount. And there's a dial on the front here that allows you to test your preemption devices. You just press a button over here and you can test your preemptions. On the back side is a whole bunch of inputs and outputs over here. So you have your preemption inputs, you've got your green sense to monitor what greens are active, and then there's a whole bunch of other aspects that you can monitor with the traffic cabinet. Is your cabinet in flash? Is it dark? We'll go over that in a second. But really important, there's a 4-port Ethernet switch here and a high-speed cellular modem that allows us to stream video, do pass-through communication so you can connect your traffic signal cabinets and get upload and download traffic signal timings. And there's a couple of outlet sockets here that you can cycle the power to. And this is actually the vehicle unit that goes into the emergency vehicle, very small unit. At the back, you wire in, your left turn signal, right turn signal, emergency lights, door switch, and it's also got, high-speed modems that connect via cellular and the radio communication. We'll have a look when we go do a little walkthrough of what all of that looks like. And then we've got, this is the shelf mount unit, so if you're wanting to have a different form factor, you can put in this different form factor. It's electrically equivalent to the other units. So really important there on the cabinet side. Normally when someone goes and puts in emergency vehicle preemption, it only benefits one party. That's the fire department or the transit agency. So what we did was we turned it around and we said, well, how do we benefit the traffic department in all of this? So what we added was cabinet monitoring and the pass-through communication. So when you have a look at the cabinet monitoring, what are you getting out of that? So I'm going to show a couple of little pictures over here. There are four main things. So we're able to do remote cabinet monitoring. That's AC voltage, cabinet flash, which greens are active, and be able to send text messages, email messages. Because the one thing you don't know, what is the difference between a power failure event, a cabinet going into flash, and a traffic signal controller failing? They all look the same from your central system. But this device has got a built-in battery that is able to tell you when there's actually a failure on any of these, anything within your cabinet. The other thing that's really important is the pass-through communication. So obviously we've got pass-through communication that allows you to connect to your ATMS system, whether it's Centrax or maybe it's, so it's Centrax or Tactics or whichever system that you have, you can actually connect into it. And directly to your traffic signal controller so you can poll the information. It looks like any other device on fiber then for you. Then obviously the emergency vehicle preemption and the priority for bus priority is another major thing. And then there's the connected vehicle aspect that we'll try to go over in a little bit later in the presentation. But it's not just one thing that the device is doing. And we're doing, AC voltage. Is the AC voltage working? We're monitoring the AC voltage every 1/10 of a second. Your preemption status. We're doing time synchronization. Your battery backup system, monitoring that. Also doing BBS. We actually run the BBS late at night to test whether or not your batteries are working. So we can actually tell you before you have a failure if your batteries are actually going to work and whether or not you're supposed to replace them. We're looking at cabinet flash, door status, fan status, the temperature and humidity. We also bring in video cameras. So if you look over here, you'll see there's actually video cameras that you can bring in, and you can stream your live streaming video cameras through the high-speed internet connection. So it's giving so much more than just emergency vehicle preemption to the traffic department. It's providing them with a whole connectivity platform. Now, if you've got fiber, we go straight through your fiber communication. But if you don't have fiber, so like a city like Baton Rouge that had 480 traffic signals, 230 of them were on fiber, and 250 of them were, I've got to do the math here, 250 of them were not connected. So those all had cellular communication, and now from their ATMS.now platform, they've got every single one of their intersections connected, and all of them are providing information for preemption. So whether or not you're running over your fiber network, we can run over a fiber network or over your cellular network. But there's a lot of cities that, it's just not worth it to do fiber at every intersection because it's just too expensive. So this is a great platform of getting other intersections connected and obviously providing emergency vehicle preemption using local radios and the emergency vehicle and the cellular communication for the emergency vehicles. One other thing over here, let me go and see if I've got this slide over here, which is providing the pass-through communication. So whether you're using Siemens controllers, Econolite, Interlite, McCain, Trafficware, I should have a Peak controller here, but I don't.
So he's going to draw us one.
There we go. We support all of their central system platforms, and we also work within the city's VPN networks. So we have various different ways of connecting to these. We can connect to them without touching the city's networks. We can connect to them within the city networks. There's multiple different ways of getting connected to all of these different devices. And it's just, each city is different. So, you just got to be cognizant of all of that. And it won't be myself, that'll be one of the IT professionals that'll work with your IT professionals in how to connect up all those systems.
So just to clarify, Peter, we can customize our system to fit into whatever the city already has, right? So if they have some intersections that have fiber and some that don't, it's not like they have to be an all matching set for these boxes to work.
Absolutely correct. So whether or not you're using the fiber communication over here, you just plug in the Ethernet directly to ours for your fiber network and we communicate over there, or we communicate just over the cellular radios. To us, it doesn't make a difference. There's a cost saving if you're going to be doing fiber versus cellular. That obviously we apply to all of those things, to provide that information.
Got it. I know you want to get into some connected vehicle stuff, but before we dive into that, I wanted us to take a look at our devices here in the iATL, real live wired ones. But before we do that, I have a question about preemption. Can we cover that before we go?
Yes, absolutely.
Okay, so someone's asking, for this style of preemption to work, do you have to have predefined and predetermined routes before you leave the fire station?
That's a great question. The answer is no. So what we do, and we did look into that and found out from the fire department and the people actually doing the work there, is they said their drivers always take different routes. A lot of fire departments have tried predefined routes, but there'll be something that a local driver knows something different than whatever system creates a predefined route. So each one of these boxes down here has a set of rules, and that's why we get into the left turn indicator, right turn indicator, so we can know whether or not the driver's turning left or turning right. And we create all these rules that creates a distributed intelligent system. So the intelligence sits within each intersection so that we can provide preemption based on every single intersection making that decision. So there's never ever one single point of failure, because if you've got a predetermined route, one incorrect intersection and then the driver stops getting green lights. So every intersection looks at the way that the vehicle's driving and creates a priority request based on that information.
Awesome. Well, are you ready to go on a tour?
So let's go. What we're going to do on the tour is we're going to go talk about school beacons to start. So we'll go look at some of the school beacon systems that we're doing. And then what we'll do is we'll walk into the second aisle. That will be the emergency vehicle preemption and cabinet monitoring aspects. So let's go do a walk over here. So this is the iATL lab, and you'll see a whole bunch of equipment on the back wall over there. And what we've done is we've created this lab for the auto manufacturers. So we've got Ford, we've got Audi, we've got the 5G, AA, Automobile Association, all coming to this facility to test vehicles and how they work with connected vehicle technology. All of our devices do connected vehicles, whether it's a school beacon unit or intersection, all of them work with connected vehicle technology. So what I'm going to show first is a school beacon setup over here. So this is a typical school beacon. Now, we've got a solar charger over here. We've got a DC flasher, and there's some wiring inputs over here. These are the two LEDs. This, you would normally have a battery in the system. We just put a small battery on this back plate to showcase it. This is the timer switch that goes into the cabinet, and I'm just going to pull off this lid over here to show you what's inside of here. So our unit's got a battery, it's got a cell modem over here, it's got a processor, and it can either run on AC or DC, and it's got two relay contacts with 15 amp relay contact closures. What's important is the cell modem is built into the units. Very important is, if any of you have dealt with cell modems before, when you put them in traffic cabinets, every now and again, a couple of months, 6 months goes by and something hangs up in the cell modem and you've got to restart it. We've got a process over here looking at the communications that's able to restart the cell modem if it detects any problems. The battery over here allows us, if there's a power failure event, to send a message that there's a power failure event so that you don't have to go and say, all right, let's send someone out there. When someone phones and says your school beacons aren't working, you know why they're not working is because, well, the power failed. We need to call the utility company to bring them in to fix it. Now, of course, we also, if I turn the switch on here, I'm just turning the beacons on, and this is just a manual override switch. We're also monitoring the individual LEDs, whether or not one has failed. So we can tell you if one beacon's failed, both beacons have failed, or multiple beacons, because this is actually connected up to the wall over there, and you'll see the beacon flashing on the wall now, and we're monitoring up to 4 beacons here to determine whether or not something has failed. This is the cell and GPS. We call it a K-cup antenna because it kind of looks like a K-cup. And this provides GPS time synchronization and cellular communication for a school zone system. So really important is obviously doing the time synchronization there and getting these connected over here. All of the schedules are saved locally into the device. It's not a central system saying, hey, turn on, turn off. You set up your schedules, it downloads it locally into flash memory that never gets deleted. So it's always stored locally, and as soon as there's any change of information, if a beacon turns on, if there's a power failure event, if the battery drops below a certain voltage, we instantly send information to the central system so that it can send an alarm or text message, email message, that there's some kind of failure.
And all those alerts are customizable, right? We can determine who those alarms and alerts will go to.
Yeah, and even different voltages and things like that, because we found out in some of the beacons in Texas, they've got a cut off at 11.4 volts, and so they wanted the alarm when it dropped below 11.5 volts, and some places 11.2 volts. All depends on when you want these alarms to occur. All of it's customizable, and also who you send it to, because often the management wants to receive something like an email, but they don't want to receive a text message, but they want their technician in the field to receive that text message. What's really important is all of this information, there's artificial intelligence that's running in the central servers that's monitoring the battery voltage, the solar panel voltage, and it provides information of whenever there's actually going to be we determine that there could be a failure in the future. Now, this is a solar beacon. We'll move over to an AC beacon, almost identical. The only difference is obviously we're just using a 204 flasher here for the AC side, and some surge protection, and it works exactly the same. There's less wires to hook up. So on an AC solution, there's round about 4 wires to hook up. On a solar, there's about 6 wires to hook up, the LEDs, the battery, and the solar panel. And obviously here it's just the power and the LEDs that you're wiring in. Interestingly enough, there's a lot of agencies that have installed these, and there's it takes about 15 minutes to 30 minutes to actually deploy this in a school beacon cabinet. It's really, really quick. Some agencies buy the whole backplate because they've got very old infrastructure, like they've got very old sun savers or whatever it is. So they actually replace the whole backplate because it's just quicker. Others, they just put the new timer switch. They take out the old RTC or LTEC timer switch, pop this new one in. We also have some wiring harnesses. So there's actually a little harness that comes out the bottom here, and we can connect into the little CPC connector of the harness of the LTEC or the RTC connector over there. So very, very simple to do. And that gives you this whole aspect of being able to remotely program school zones, especially in this era. I don't know how many times around in our area we've had school schedules changing. The school start time is changing. And daily it's changing. So we actually just don't know when schools are going to go back. It's a great mechanism to be able to program your beacons remotely without having to send someone there and go and check in on that. Huge factor with all of those things is if you leave your school beacons on, people in the public stop relying on that information. So what they do is they just ignore it. Now when your school beacons are flashing, they're not looking for children, even though children are in session, because you just left it running for the whole summer vacation instead of turning it off. And the studies are showing it takes 8 times of showing the information correctly before someone in the public believes in the system again. So it's really critical. We also have ways of doing snow days, hurricane evacuations, where you can turn off all your beacons with one click of a button. When COVID-19 hit, our customers with one click of a button turned off all their beacons for the following day. Very, very easy to do. This same unit can also be used for other applications. So this is a railroad warning device that we connect in and we provide, you'll see on the wall there, when we get around to that, there's actually a railroad warning unit that we flash when the railroad crossing is actually active ahead. Then we come on to radar feedback signs. So the same unit, because radar feedback, sometimes you've got a radar feedback sign in a school zone, or it's in it's generally in a position where you're wanting to reduce the speed. What we're able to do is collect all that speed information and also configure the radar. So when you look at a radar here, this is showing what the current speed is, but in the radar, you want to collect your median speed, 85th percentile speed, volume of vehicles, and bring that all back. Instead of going there with a Bluetooth device or downloading from a dongle, all of that gets collected straight from the central system. And some of the times, in very progressive areas where they've got really a lot of speeders, people actually put this sign with this sign joined together. So they flash the beacons and they have a speed limit sign here. Now what we do is we dynamically change the speed limit thresholds on the driver feedback sign when it's in a school zone area, because school zone speed limit's 20 miles an hour now, whereas when the school zone isn't flashing, it's 35 miles an hour. So you've got to change the message of slow down or flashing on this when school beacons are on. So we automatically do that. So the system communicates to it via serial communication and changes the speed limit information on this sign, so that when the school beacon turns off and you leave the sign on, it's providing information to the driver, slow down only when he's driving over 30 miles or 35 miles an hour, slow down messages. So it's a great way of interfacing the two systems together and collecting all of that information back from these signs. And this is this railroad crossing sign over here. You'll see Front Street crossing in use an alternate route. That's actually a pretty cool system when you've got railroad crossings that get blocked. we can actually activate beacons at all the decision-making points, where we actually monitor the railroad crossing from the traffic signal side. So that's a little bit about school beacons. We'll jump in a little bit more about school beacons when we sit down. But I wanted to show, a little bit more how you wire these things in, how they connect up. What I wanted to do was go into the emergency vehicle preemption. Before I go there, Jessica, we're just going to show them what a vehicle unit looks like. So this is actually the vehicle unit here with a test box, which normally the traffic department uses to simulate when the vehicle's emergency lights are on, left turn, right turn. And then we actually we had to create this suction cup because all of these F-250s have now become aluminum, and the magnetic mount antennas don't attach to them. So we've got a little suction mount here that you can plug on, and it just plugs in with a cigarette lighter. So it's very easy for the city to actually go and monitor these things. If we go into a traffic cabinet, so this is a NEMA style cabinet over here, and we've just got our unit on the box over here. And what we do is we connect in to the traffic signal controller over here. So we've got Ethernet connected to the traffic signal controller. This is a Siemens M50 here. And then we also connect into the conflict monitor, which is around here in the corner. And then there's a bunch of wiring harnesses at the back of the unit here that get wired into the cabinet. So we're monitoring the AC down here. We're monitoring the green sense. So we can tell you whether or not a vehicle got a green light, because we're actually monitoring the green phases, and we can say without a doubt, when that emergency vehicle went through, phase 2 and 6 were active, or phase, whichever phases you've got configured for the device, we can tell you exactly which ones are active. This unit's obviously connected in via preemption. For this unit is hardwired, but there's also other ones where we've got Ethernet-based preemption, depending on what the controller supports. So this is a NEMA-style cabinet, but over here is a Caltrans or 332 cabinet. So you'll see this is our 19-inch rack mount unit here mounted in, and here they've got a Interlight controller running NTCIP, but they've also got a Clary battery backup. So we're able to monitor the battery backup system, determine is the battery backup on, is it running any alarms, are the battery voltages starting to die, and we can even trigger through Ethernet tests for the battery backup. So it'll actually run late at night on the actual batteries down here. It'll run a test to actually determine, are the batteries working? Are they holding their charge? Because the worst thing you can have is a power failure event and then your battery backup system doesn't work. We've also got here iTerra's video detection. So the iTerra's video detection cameras, and these cameras sitting up here, that we can do video streaming on. So you can stream the videos, you can configure the cameras, you can do everything with it straight over a cellular modem, which is a great way of getting connected. At the back of this cabinet, there's, they actually installed a panel over here to make the wiring a little bit neater. So this is a panel that a couple of our distributors are doing, Temple, Paradigm, bunch of different people that can make these little panels here that connect up and just make the wiring really, really neat going into your traffic cabinet at the back. All depends on what you want. Really important, on top of the cabinet, this is what the antennas look like. This is the dual MIMO cellular and GPS antenna. So this does high-speed cellular communication. And then there's a 900 megahertz radio over here, which is providing 900 megahertz communication for the direct line of sight for the emergency vehicle. What is important is you have a look here also on this cabinet. We also recommend always installing these two antennas on opposite ends of the cabinet. Install the 900 megahertz radio on the edge of the cabinet that's got the best line of sight for your street, and you put this antenna on the other side of the cabinet to make sure that you don't have any crosstalk between the two. You could probably put them closer together, but in our experience, it just works better when you put those two antennas further apart. Now, down this aisle is really cool because this is all of our connected vehicle stuff, which we're going to be doing another session on that. But what's really important is we connect to every type of traffic controller out there. So whether it's an Interlight controller running on Siemens hardware, or it's a Virginia DOT D4 software. I'll go over that a little bit later. Peak traffic controllers, whether it's NASTEC, the older Series 900s, or their ATCs, or their latest traffic controllers, we connect to all of them. We're able to get their SPAT information. And on the preemption side, the intersections like the new Siemens software and the new Cobalt software can actually do NTCIP 1211 communication for preemption. It's a pretty cool way of doing it because what we're doing is we're providing the ETA to the traffic signal controller and what phases we're requesting. So what ends up happening is the traffic controller can get this information from a much further distance away to keep the traffic controllers in coordination. So what that really helps with transit signal priority, but obviously emergency vehicle preemption also becomes a lot better. This is a new Econolite EOS software controller over here, where we're doing a whole bunch of stuff with Econolite. We're doing a massive project with them in Hawaii, and connecting, providing emergency vehicle preemption, providing connected vehicles, and all the rest. I'm going to quickly walk around this side. We're not going to go over it, but this is all DSRC radios, CV2X radios over here that we're going to go through in one of our next sessions. But even if you've got an old traffic controller, a 170, we can work with these and do connected vehicle applications as well, even with 170 controllers. So it gives you a great way of getting connected to everything. We build up those SPAT messages. We also have a DSRC CV2X radio system as well. I won't have time to go through that today. Please, if you do want to learn a little bit more about that, contact training at App Info Inc. and we'll go through all of that. So why don't we sit down, Jessica, and then we'll go through some of the other applications and some of the things with school zones as well.
Right.
So the first thing I'm going to ask you is, do we have any questions as we've been walking around? Because we've been walking around for a little bit, and I'm pretty sure you've got some questions there.
Yeah, so we have someone asking, what's the name of the school flasher?
Okay, so the name of that school flasher is a AI 500-070 FCU, Flasher Controller Unit. So that flasher controller, we call it a glance remote school beacon management system. And yeah, it depending on where you are, there's also a different nomenclature for Florida, which is an 071. And so yeah, it's called a 500-071 glance school zone timer switch.
And then we have someone asking, do you have to have both, or I guess they're asking, do you have to have preemption enabled in order for pass-through communications or cabin monitoring to work, or can you pick and choose what you want in your city?
Great question. No, you can, the unit's got those 4 major functions. You can run just cabinet monitoring, just preemption, or just the remote communication. So the great thing with the remote communication, it's pretty much the only NEMA TS2 rated cellular modem on the market that's gone through all the NEMA testing. So it's wide temp, works, it's been approved by Florida Tyrrell and all the different agencies. So, it provides that cellular communication very easily.
All right, and one last one for you, Peter. They're asking, can we mount the antennas other than drilling holes through the cabinet?
Great question. Yes, so there are some other options. We can run some cables up onto the pole. So we run the cables from the units, put it up on a pole, a little pole mounted unit. In North Carolina, we did some basically L brackets that they use really heavy duty tape that they put it on to the side of the cabinet. So there are multiple different ways in Quebec City in Quebec. What they did was they're running cables and they're putting both antennas on top of the signal poles. It just depends on what you want to do. So absolutely, it's a lot cheaper to obviously put it on top of the cabinet, and because you don't have to run any cables. Obviously, what we recommend is putting sealant on it. But if you've got a policy that you can't do anything, absolutely, we'll work with you guys in terms of putting those antennas in a remote location, not on the cabinet.
Great. Well, y'all keep those questions coming. We'll keep bothering Peter with them here in a second as he continues.
So one of the important things that I wanted to go over, just on the school beacon system, is going through some of the information, like what is actually getting monitored. So obviously we're monitoring the LEDs, so monitoring the AC voltage, monitoring the solar panel voltage, and the batteries as well, and providing these alerts all the time. So lamp failure alerts, AC voltage failure alerts, and so on. There's one interesting thing from Tom Seaver over here from Gwinnett County, that they looked at their system and they showed that they had a 90% reduction in the number of service calls that came in. You have all these soccer moms calling in and saying, oh, the school beacon didn't turn on at the right time. And they had to send people out there all the time. And when they actually put in the system, they were able to monitor all of these things. One really important thing as well is, we obviously do school zones, the driver feedback signs, and obviously pedestrian crossings. Is, this is Georgia DOT, where they're monitoring 800 different beacons, and it's all connected via the Glance platform. Now, we probably don't have enough time to go through the whole Glance platform, but this is, you're able to remotely schedule the beacons through here. You're able to get any alerts on the beacons, and it'll flag up if you got any conflicts or anything like that. Very, very key with the whole system is, when we deploy a system like this, people expecting to have this work for the next 10 to 20 years. So when you're doing a communication system with cellular, how do you do that? So what we do is we make sure that that we guarantee communication. So we've got roughly 18,000 devices deployed around the US, and we don't have any units that can't get connected to the internet. You use a bigger antenna or whatever it is, we guarantee the communication. So we've always asked people, challenge us, we'll get you connected. Also very important is the ability of having a warranty maintenance period on all of these different devices. Jessica, can you explain how that warranty works? And
so when you buy our connectivity and support, we're going to upgrade you from whether we went from 2G to 3G, 3G to 4G, and whether we go to 5G, LTE, all that stuff. We are going to take care of you. We're not going to just put our device in the field and then abandon you and say, figure it out. We don't know. We already sold it to you. We're going to take care of you, and we guarantee in that warranty that we will upgrade to you to whatever system we are running next.
Yeah, and that also includes the warranty as well.
Yep.
So
if a lightning bolt comes and hits your system, right, we are going to replace that for you. If anything goes wrong, let's say our battery, we're supposed to be monitoring voltage, but for some reason it didn't, and it spiked and it caused the unit to no longer be functioning, we're going to take care of that in that warranty.
And that's what's really cool with that warranty is you also getting a 5-year or 10-year warranty. So when we provide these systems, they come with a 5-year or 10-year connectivity and support. So that means that we're on the hook for the next 10 years to make sure your system works. We've got a lot of customers with 10-year warranties. So, we've got to back up our product and ensure and guarantee that cellular communication works. The great thing is all of that money is done at capital expenditure, not operational expenditure. So there's no maintenance costs or anything like that. It's all in the upfront cost. You buy the system, it gets connected. Then, let's say after 5 years, what happens? All you do is you re-up the connectivity and support, and you're covered for the next 5 years with another 5-year warranty and another 5-year guarantee in cellular communication. That connectivity and support also includes the travel safely connected vehicle applications that we'll show in just a second as well.
Yep, and we have a couple questions here. One was, what are the terms of the warranty? So you just covered that. It's whatever you select, and then you can just renew. And then someone is asking, we have recently...
Sorry, just on that,
Yep.
It's an unlimited warranty.
Yes.
No matter what happens, you send it back to us, we guarantee that our equipment works. Now, if there's some major flooding event or whatever it is, and you lose 200 school beacons, generally insurance is going to cover that. But if you guys drop the unit by mistake, send it back to us, we'll fix it for you for free. There's no cost at all.
Right. So someone's asking, we have recently purchased 10 radars for school zones. Can we remotely monitor these devices from TMC?
The answer is absolutely yes, but it depends on the radar devices that you have. So your radar feedback signs, we currently are connected to 3 different manufacturers. It's Comana or IDC, Comana Board IDC, Comana Speed Check or IDC Speed Check. We're working with Traffic Com, and we're working with RU2. Now, if you have another manufacturer, you just have to let us know. We're willing to integrate with any manufacturer out there. So if you say to us, hey, we've got this sign from this person, as long as they're willing to work with us as well, we'll integrate to theirs, no cost at all, and to bring that information back to you.
Awesome. It sounds like a little bit of a challenge here. It says, in rural areas where cell service is hit or miss, what are the other options we would have to establish communications with the school flasher clock to program it?
I love that question. I challenge you to take me on. So we did the whole of Georgia, every single beacon in Georgia. Remote beacons, we've done Missouri, every remote beacon in Missouri. We've done state of Maine. We've gone all over the US, Alaska. We still haven't hit one location that we can't get cellular communication. It's a case of using, because our antennas have a much higher gain than your smartphone. So even if your smartphone doesn't get connected, the guys go and install our equipment, and then they drive down and then they go test whether or not it works, because they can see on their smartphone when they get connectivity. But I challenge you to get to find a location we can't get connected to, because what we'll do is we'll use a directional antenna then. It's one of those things that we guarantee communication.
Peter, the questions are flooding in, so we're going to zip through these. The lamp monitoring feature, can you monitor LEDs as
yes.
well?
So we monitor LEDs and incandescent bulbs. We do both. And our units can monitor 4 LEDs as standard, and then we can also do up to 8 LEDs where we tell you that there's multiple lamp failures, because we've had a couple of places where they have 6 LEDs connected to one string. So we'll actually say, we can do 4 individuals, or we can do up to 8, and we just tell you there's multiple failures then when there's more
Texas
than that.
has some of those.
That's right.
How effective is the system when it switches to battery backup mode?
Great question. So what we do is our unit runs for about 5 hours running on the battery on the school zone. So on a school zone, we're going to run for 5 hours. When that cuts off, obviously our unit goes offline, and then as soon as AC is restored, you get another text message that the AC power has been restored. On a traffic signal cabinet, if it runs on battery backup, we obviously connected to the battery backup system. power, so we'll run as long as that, and then when it fails, we run off our internal battery. On a cabinet system, it's about 3 hours of run time. But all we really need is that last gasp to tell you the power's totally failed. Get someone out there with a generator.
Awesome. And then 2 more, and then I know you want to show 1 more video before we end. So we have someone asking, what's the cost of a system like this for remote monitoring for school beacons?
Give you a rough order of magnitude. If you're going to go connect this in, in-stored, it's about $2,500 for 5 years of connectivity. Probably about $3,000 for 10 years of connectivity. Maybe $3,100. It depends on number of units you're purchasing and so on. And a cabinet system's roughly about $5,000 with, emergency vehicle preemption. Between $4,500 and $5,000, depending on where you are and the cost of installation and so on. Also, prices change depending on whether or not you're doing video or whether or not you're doing running over your fiber and so on. So each one of these systems is customizable in the pricing. And if you want to get a cost for your city, just reach out to us, and we'll put you in contact with our distributor in that area, or set up one of these calls where we can bring you in to this whole area here.
Awesome. And then someone is asking, what's the longest time span we've had one of our preemption systems installed in a city?
Great question. Roughly about 4 years, somewhere around there, 3 to 4 years, that we've got our preemption systems deployed, somewhere around there. And yeah, we first started off with cabinet monitoring, then we added in preemption and priority, then we added in connected vehicles, so we constantly adding in. Now we've got virtual buses coming in to do bus priority, so there's new features all the time. And a key aspect behind our technology is we have over-the-air software updates. If I had to recommend one thing to look for in any new purchase that you have on electronics, it's over-the-air software updates. I mean, you couldn't imagine buying a smartphone and the day that you buy it, you can't download any new apps. It's the same thing with traffic equipment. You want to be able to upgrade your system without sending a traffic technician down there with a dongle or computer to upgrade it. All of our devices can be remotely upgraded so that you can get new features, new functionality, because we've got 580 cities on the system that are all requesting new features all the time. So everybody gets these new features whenever they come out, which is absolutely great. And connected vehicles and all those things are changing. We upgrade all of that information as well.
Awesome. Well,
so one of the other things maybe you want to do just before everybody goes off is show them some of the stuff we're going to see on connected vehicles in one of the next sessions. So I'm going to show you a quick short video before we wrap up here on connected vehicles.
Meet Travel Safely, an app that helps you get where you're going safely. Travel Safely works if you're driving, walking, biking, wheeling, scooting, or skating. Get real-time audio notifications.
Red light.
So you can focus on your surroundings. Get notified when you're approaching a red light or when it's time to get ready for green.
Get ready for green.
Travel Safely works with local emergency vehicles, helping them respond to calls faster. Get notified when an emergency vehicle is approaching,
Emergency vehicle front.
or when to share the road with your two-wheeled friend.
Cyclist. Vehicle approaching cyclist.
Travel Safely tells you when you're passing a school or work zone, and if you need to slow it down. So whether you're on the road or just crossing,
Pedestrian.
every time you open Travel Safely, you're helping make a better commuting experience for all of us. Together. Download the Travel Safely app today and join our community of users committed to making our roads safer.
So that's just a little teaser for the next session. I'm not going to go over any of those things. There's a whole bunch of features. We've hit our hour limit here. So I want to make sure, I know we didn't get to answer every single question. We will reach out to anyone that's asked any questions and get back to you as well.
Yeah, and like we said, if you are interested in scheduling a private session to learn more, whether that's technical or a solution for your city, you can just reach out to training@appinfoinc.com. We're going to be participating in that IMSA August conference. We're going to have Peter back here again. We're going to drag him back to the IATL. So reach out, and we hope you've enjoyed our session.
And one last thing, just to add in, if you guys are wanting any demo units or anything like that, contact us. We provide a lot of demo units out there. Give us a shout. Love to hear from you guys, and thank you so much for joining us today.